Alright, today we will be talking about partial derivative. That's 201 partial derivative. Partial derivative. Very interesting topic. And so we said that if let z, for example, be a function containing two independent variables. In my previous video, I already explained why I used to say two independent variables, right? Let z be a function containing two independent variables, be a function of two independent variable x and y. Then z plus the z, or changing z, is equal to fx plus this, keeping this as constants. Then we have the z equals f of x plus changing x minus y minus z. So we have the z equals f of x plus changing x comma y minus f of x comma y. Anyway, this is first principle if you are trying to differentiate from first principle. But because we are doing CBT exam, photo-based mathematics for Maths 201, photo is CBT, and so because of that, we will just be going into the nitty-gritty of partial derivative. We won't be boring ourselves with the first principle. All right, so partial derivative is just simply differentiation while keeping the other variable as constant. You simply differentiate while keeping the other variable as constant, keeping the other variable as constant. So you are simply differentiating, but you are keeping other variable as constant. All right, so we will just be going into the nitty-gritty quickly. Let us go into the nitty-gritty of that quickly. Partial derivative, differentiation. And so because we have a foundation in differentiation for our first level, our 100 level, it makes it very easy for us to comprehend what we are doing. It makes it very easy for us to comprehend what we are doing. So let's say example 1. It said if f containing two independent variables is equal to x squared y plus xy squared. It said find f of x and find f of y. Okay, simple, very easy. Why did I say it is very easy? Now, f of x. So we cover this and differentiate. Now, because we are treating with respect to x, the respect we have for this equation is that of x. It's only x we want to focus ourselves on. So what we are doing is that we will pretend as if we did not see this guy. We will pretend as if we are not seeing the other variable. Not just pretend. After differentiating what we came here for, then we just multiply it. So let's do that quickly. Now, if I cover y here and I have x squared, if I differentiate the x squared here, remember, we are paying homage to x. We are differentiating only x. That's why it's called partial derivative. So, differentiating with respect to x will give us 2x, right? Then you just multiply by the y. Remember, we pretend as if we don't see this y. So after we have done what we want to do, we multiply by y. So 2xy plus, again, we are only paying respect to x here. So If you differentiate x there, you have 1. You have 1. And so 1 multiplied by y squared is y squared. Y squared. It's as simple as that. It's as simple as that. F of x. So what will be f of y? Again, this time around, you came here, or you are coming to differentiate with respect to y. You have no business with x. It is only when you are done with your differentiation that you can multiply by the x. So with respect to y of this function is, if you differentiate with respect to y here, if you differentiate with respect to y, you have just 1. Right? Differentiating a constant is 0. But if you differentiate just y here, you have 1. So 1 multiplied by x squared is x squared. If you differentiate y squared here, what you're going to be having is 2y. Remember, we are paying homage to just this y. So if you differentiate y squared, you're going to be having 2y. And so once you are done differentiating, multiply it by whatever variable is left. So 2y multiplied by x, you have 2xy. As simple as that. It's as simple as that. So f of x is this, f of y is this. Okay, we will be looking at some other difficult or more difficult things. All right, let's look at something more difficult. Let's look at something more difficult. Okay, it says if f of x comma y is equal to x e y minus sine y over x plus x to the power of 3 y squared. It says find, want to find f of x. Want to find f of x. So what would be f of x? Again, let's come to this junction and pretend as if we did not see the exponential of y, e to the power of y. So if you are differentiating this function, just this place, if you are differentiating this function, you're going to be having just only x. You're differentiating only x, you're going to be having 1. Right? If you differentiate x, you have 1. So 1 multiplied by the other people you pretend not to see is e to the power of y. Did you see that? We are addressing only x. We are addressing only x. Now we move to this junction. But this junction, you see, is quite dicey. Why is it dicey? It is dicey because you have a sine of y all over x. So let's assume that we have w is equal to a sine of y over x. Let's use our knowledge of maths 102. Let's assume that let y over x be equals to, let's say, p. So what I'm seeing here is w equals to sine of p, right? So the w, the p, is, if you differentiate sine, you have a cos. But if you differentiate cos, you have a minus sign. So a differential of sine is a cos p, right? You differentiate sine, you have cos. And so if the w, the p, is cos p, then what we need to do is to do the p dx, because because this is chain rule. What I just did here now is chain rule. It's called chain rule. Chain rule. So the p dx, the p dx. Remember that p is the same thing as y x to the power of minus 1, right? So if you are saying the p dx, the p dx will be minus yx minus 2. What happens here is that the minus here goes down. So minus 1 multiplied by y is minus yx. And then you borrow 1 upstairs. Remember, whenever you say a to the power of x raised to the power n, if you are differentiating this function, your answer is n a to the power of x n minus 1. You are always borrowing 1. So in that case, what you have is what? Minus yx raised to the power of minus 2. So the p dx is the p dx is minus yx to the power of minus 2. And so we now say there exists a point where the w dp should be multiplied by the p dx. So we say cos p should multiply minus yx minus 2, right? So we say so this is cancelling out, yeah? So we say cos p multiplied by, now if you write this is the same thing as minus y multiplied by 1 over x squared, right? Yeah, because minus yx to the power of minus 2 is minus y times 1 over x squared. And so this can be translated or loosely translates to cos p times minus y over x squared. Did you see that? So this is, now recall that p was what? What was p? P was y over x. P was y over x. So we have, so you're going to be having minus y over x squared into bracket cos y over x. This is the differential of this person here. So what we have is, now recall that there is a minus here. What did I say? Recall that there is a minus here. So when a minus multiplies a minus here, you have a plus, a positive. So we have positive, we have plus, did you see that? Plus y over x squared cos, did you see that? Cos y over x. Did you see that? Now plus, what will happen when we differentiate this with respect to x? So we are going to pretend as if we didn't see this y squared. So we are going to attend to this guy, x to the power of 3. And so when we attend to this guy alone, if you differentiate x to the power of 3, you'll be having 3x squared. Is that not? Okay, 3x squared. And so you multiply it by y squared, you have y squared here. So basically, this is the differential with respect to x of this function, this whole function, this total function. This is the differential with respect to x. All right. Introduction to partial derivative. Introduction to partial derivative. Okay. Let's look at something new. So what will be f of y? What will be f of y? Okay. So f of y, as we all know it. Now this time around we are paying respect to y. So we have exponent of y, exponent of y, exponent of y. When you differentiate e to the power of y, you're still going to have e to the power of y. Because the law of differentiation says that when you have e to the power of ax, our answer is a e to the power of ax. And so this a here, in this case, represents 1, because 1 times y is y, right? 1 times 1 is y. So we now said that the imaginary 1 here should come down. 1 multiplied by e to the power of y is e to the power of y, right? So now that we have paid attention to this person, e to the power of y, we have been able to differentiate e to the power of y. We said it's e to the power of y. Now let's multiply that by x. You have x e to the power of y. Exactly the same thing, right? Exactly the same thing. So what will be the differential of this with respect to y? You can tell me. Let's do that. Let's do that quickly. Let's differentiate this with respect to y. Let's differentiate that with respect to y quickly. With respect to y. And so with respect to y, let's do that. We have sine of y over x. So we say let y over x equals, for example, d. Let's just say w is equal to this. We want to use chain rule approach. So we have w is equal to sine of d. Sine of d. So in differentiation, what is outside affects what is inside. So we say dw dd. Do you see that? The W, the D, and not the other way around. You can't say the D, the W. In fact, what you are going to say is the W. So that, for example, if I have y is equal to sine x, I don't say the x, the W, the x, the y, sorry. What I'll be saying is the y, the x. So what is outside is calling upon what is inside. Differentiation of x, differentiation of y with respect to x, differentiation of y with respect to x. So what is outside determines or calls upon what is inside. All right, so let's translate that here quickly. We have w is equal to sine d, so we say the w, the d, right, and the w, the d is cos d, right. Now it is left for us to now say the d, the y. You know that, right? The d, the y, because we are differentiating with respect to y, don't forget. So the d, the y. Now remember that d is y x to the power of minus 1, because y over x is the same thing as y x to the power of minus 1. So the d, the y is x to the power of minus 1, because if you differentiate y here, you have 1 multiplied by x to the power of minus 1 is x to the power of minus 1. So we have x to the power of minus 1. So we say the w, the d should multiply the d, the y. This cancels this, and so we have cos d should multiply x to the power of minus 1. Right? So what I'm simply saying is, let's clean this. So we are saying minus, now we have differentiated this function. Haven't differentiated this with respect to y. What we are having is x to the power of minus 1 cos, you said cos d, right? Cos d. But what is d? D was what? Y over x. So we have y over x here, right? Okay. Y over x. And so the next thing here is to differentiate with respect to y. If we differentiate this function with respect to y, what do you think we're going to have? If we differentiate with respect to y here, we have 2y multiplying x to the power of 3, right? So in proper terms, what we have is f of y is equal to x to the power of y minus x. Okay, you can say 1 over x, right? 1 over x cos of y over x plus 2y x to the power of 3. That's just it. Wow, wonderful. So this is f of x and this is f of y. Partial derivative. Introduction to partial derivative. All right, so let us talk about something very important in partial derivative, which is called the chain rule system. Screen our board quickly. The chain rule system. The chain rule system in partial derivative. The chain rule system. What do I mean by chain rule? Okay, I'm going to use a question to explain, right? Let me explain using a question. So we said if f, a function containing 3 independent variable system u, v, and w, is equal to u to the power of 3 plus 2uvw plus vw squared. This is a function. right? And then u is equal to xy, v is equal to x minus y, w is equal to x over y. It says find the f, the y, and also the f, the x in terms of x and y. Of x and y. Wow. Wonderful. 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 This is powerful. So, what does it mean to say chain rule? All right. Let me explain using a house. Let's use a house as an example. So, imagine, or let's assume that you have a baby girl here. You have a baby girl, and you ask this baby girl, for example, in this room, this is room 1, this is room 2. Let's assume there's another room here. This is room 3. And then you ask this lady to go and bring a pillow that is in room 1, room 2, room 3. A green pillow, for example. A green pillow. Do you know what she's gonna do? You ask a 3-year-old baby to go and bring a pillow. Do you know what she's gonna do? She will go to room 1, pick the pillow, go to room 2, pick the same green pillow, go to room 3, pick the same pillow, right? Because you asked a baby girl to bring a green pillow. And those pillows are common to everybody. So she's just gonna go there, pick a pillow here, pick a pillow here, pick a pillow here, and bring them to you for you to choose. That's how babies do. So the same idea comes into play here. So this is the father F, having 3 babies, U, V, and W. And now each of those babies have children, X and Y, X minus Y, X over Y. What comes to our mind is that to find, for example, the F, the X, chain rule now. So chain rule is like simply saying there's a father here, and there are children here, and there are grandchildren. So father calls the child calls the grandchild. So father calls the child calls the grandchild. So, having said that, it means that the fathers of these 3 children, U, V, and W, these 3 children gave birth to similarities. X, Y, this case is multiplying, in this case it is minusing, in this case it is dividing. Alright? So, if I want to find the F, the X, chain rule. If I want to find the X, the X, what are we saying is, let this father call one of the child, the F, the U, and then he says, hey, hello, how are you? Are you doing? He says, I'm fine. Is your son at home? Yes. But because we are respecting X, the F, the X, we are respecting X. So he said, call X for me. This child is saying, the father calls the child calls the grandfather, this X here. So we say, multiply it by the U, the X. Do you see that? He says, the next person, he said, hey, father, call the second child. He says, the F, the V, the F, the V. And so this V is around. They say, hey, V, now you call X out for me. He says, okay, multiply by the V, the X. Okay, the next person, he said, hey, father, how are you? He said, okay, call the third child for me. The third child, which is W. He said, okay, the F, the W, multiplied by, okay, W, are you around? We are respecting X in this case. We're respecting X. He said, okay, are you around? He said, yes. The W, the X. The W, the X. That is it. Wow, beautiful. Now, Haven't said that. Haven't said that. Let's look at the f, the y. It says, okay, the f, the y, simple. Hey, father, call your first child, the f, du, multiplied by, hey, first child, call your y. Now we are expecting y. So, du, the y, plus, it says, hey, father, call your second child. So, yes, it says the f, the v, and it says, okay, a child, call y out, because this time around we are expecting y. The v, the y. The v, the y. Plus, it says, hey father, call your third child. He said, okay, the f, the w, and it says, hey third child, call y for me. And it says, the w, the y. Beautiful. Beautiful, isn't it? Good. So it is now left for us to start finding these people, to start finding them one after the other. Okay, let's look at that together quickly. Okay, so okay, all right. So what is df du? So we said that df du, differentiation of f with respect to u. So df du here, let's list that out. Can I clean this part? Yes. Let's clean this part all together. So df dx this time around. So we said df du, and what is df du? Differentiation f with respect to u, which is 3u, right? 3u squared, because these two, 3 comes down, then minus 1, 3u squared, right? Plus, did you see that? If you differentiate with respect to u here, you have 2vw, because this u goes as 1. Differentiating u here is 1. So you have 2vw. 2vw. So we said df du, right? Multiplied by du dy. Du dx, sorry. Du dx. Multiplied by du dx, because we are differentiating with respect to x. Du dx. So what is du dx? We all know that is y, right? That is simply just y. Y. So we write that here. So we say plus. What is the next thing to write? Df the v. Df the v. The f with respect to v, df the v. And so if you differentiate df the v here, because there is no v in this place is 0. Whenever you are differentiating a variable and that variable is absent here, it's cancelled out. That's 0. We are going to go to this place. So the f, the v, will be 2uw, right? 2uw. Is that correct? 2uw. 2uw plus, right? 2uw plus df the v, multiply by the v dx, 2uw plus. Now if you differentiate with respect to v here, df the v, what do you have? Df the v, you have w squared here, right? Yeah, you have w squared. Now let's multiply this by the v dx. The v dx. So when we differentiate v with respect to x here, what do we have? We have 1. The v dx, we have 1. We have just 1 here. Okay. Okay. Plus. Now the f, the w. So there's no w here, so this is cancelled out. There's w here, so if you differentiate the f, the w, you have 2uv. You have 2uv plus, let us approach this. The f, the w, this is 2VW. 2VW. Yeah. So 2VW multiplied by the W dx. The W dx. Meanwhile, this can be written as x multiplied by 1 over y. Right? So the W dx, if you differentiate this with respect to x, this is 1. 1 multiplied by 1 over w, 1 over y, that's 1 over y. That's 1 over y. df dx. df dx. And so from here, we can find out that the f dx is let's look at that together. We have we have 3. Now let us replace. At this point it says replace, substitutes the values of u, v, and w. So what I'm seeing here right now is 3 into the bracket of, so I'm not going to write u again, I'm going to write in xy. This is xy all squared plus 2 into the bracket of, I'm not going to write v again, this is v, I'm going to write x minus y, alright, and w, I'm not going to write w again, I'm going to write x over y, multiplied by x over y, right? Okay, multiplied by y, did you see that? Plus 2, now u again, we have u, I'm not going to write u again, I'll be writing xy, then w, we have w, I'm not going to write w again, I'll be writing x over y, but we have 2uw plus w squared, so we have x over y all squared, right? Multiplied by 1, so we just don't need to write 1 because 1 multiplied by anything is that thing. Then plus, when we get here we have 2uv. So what is v? V is xy, so we have xy, v is xy into the bracket of v, u is xy rather, we have 2uv, so u is xy, v is x minus y, and we have plus, you see that, plus 2vw plus 2, what is v? X minus y, right? X minus y, 2vw, and what is w? X over y, right? X over y, okay? X over y. So when you have that into the brackets of 1 over y, so at the end of it all, the chain rule system, your df dx will be, if you break this down, we have 1 over y squared into the bracket of 2x squared y to the power of 5 plus 6x squared y squared minus 4x y cubed plus 3x squared minus 2x y. That is the value of df dx. it might interest you to find out what the f, the y will be. What will it be? What would the f, the y be? So you can do that on your own by practicing. Feel free to pause the video and solve the f, the y. At the end of your calculation for the f, the y, I think you should be having something like this. At the end of your calculation for the f, the y, you should be having something x squared over y to the power of 3 into bracket 3x y to the power of 5 minus 2x to the power y to the power of 3 minus 2x plus y. Should be having something like this. Yeah, so feel free to try that out. Introduction to partial derivative.